Hey, welcome to Are You Service Mesh Ready? My name is Jenn Gile, Product Marketing Manager for NGINX, focusing on our microservices and Kubernetes projects and products. And I've got Kate with me. Hey, Kate.
Hey Jen, my name is Kate Osborn. I am one of the engineers on NGINX Service Mesh, and I've been focusing a lot on integrating with the NGINX Ingress controller.
All right, so Kate and I are going to be talking about how you know as an organization if you're ready to adopt a service mesh, as well as the process that you ought to go through when you're selecting one. And we'll start a little bit with some of the basics of service mesh technologies just to kind of get us all on the same page. So at NGINX, we do talk a lot about production grade Kubernetes, with the idea being that it's not just good enough to be running Kubernetes, but the whole point is to get it into production and have it be automatable, releasing frequently, et cetera. And there are some components that you need in order to make that work. And so the first one being a great ingress controller, the second being a WAF, and then the third, once you're ready for it, is that service mesh. So that's where we are in this session. And Kate, I think the elephant in the room with Kubernetes, or maybe it's not even the elephant because everyone talks about it, but Kubernetes is complicated. Kubernetes networking is complicated. Uh, kind of explain to our users why you find that to be true.
Yeah, so the Kubernetes network model is really cool. It allows us to share machines between applications without having to dynamically allocate ports. So this allows us to run our distributed microservices applications with relative ease. However, this network model introduces a lot of complexity. So when I first started working with Kubernetes, I was completely overwhelmed with everything that I had to learn, from like the core concepts such as services, pods, containers, replication controllers that make up the key abstractions of Kubernetes networking. You also have to learn how to deploy those resources in Kubernetes, how to expose those applications outside of the cluster, how to provide storage, configuration, security, the list goes on. But then even when you have your application running, you still have to figure out how to monitor it. So Kubernetes can be a black box. There's not a lot of tooling available for you to collect metrics or monitor your applications. It also can be extremely tricky to debug your applications when it's running in a cluster. Those traditional layer 3, layer 4 networking tools that you would use don't always apply or work in the same way inside the cluster.
So there's just a ton in terms of both the learning curve involved once you start, as a developer in Kubernetes, but also you can't take your favorite tools necessarily with you and they won't work the same way, right?
Yeah, exactly. Spot on.
Okay. So let's get a little bit deeper in about these networking layers. What's missing in Kubernetes and what is it that you really want and need from a service mesh?
Yeah, so what Kubernetes provides you is a lot of network tooling for the layer 3 and layer 4 space. So in addition to what it provides out of the box, it also has a really robust ecosystem of networking tools that integrate with it or extend its networking capabilities. So we added a link on this slide that discusses the Kubernetes network model as well as lists the third-party projects that implement it. At last check, there were 35 some projects listed. So I think that's a really good representation of just how complex Kubernetes networking is, that you have 35 different tools to choose from. On the other hand, it also shows that Kubernetes is really extensible, and it allows us to bring a unique set of tools to that ecosystem when needed. So like you mentioned, it's also missing something. It's missing that layer 7 traffic management aspect. So layer 7 is the traditional application delivery networking where HTTP lives. And this is something that we talk about a lot at NGINX and F5 because it's where our products live. We are in the business of making sure that services can access applications and that your applications are always up and highly resilient. For us, it's great to work in this Kubernetes space because it provides us with the opportunity to fill this gap. And that's where Service Mesh fits in. It provides that layer 7 traffic management.
And service mesh is, a fairly new technology, and it's something that we hear regularly, people saying, okay, I think I need one, but what is it? So let's dive into what is a service mesh.
Yeah, so service mesh is like I said, really focused on that layer 7 security and application delivery space. It allows you to configure things like rate limiting, circuit breaking, access control, mutual TLS, things like that. One way to think of it is that it kind of takes over where Kubernetes networking leaves off. It also provides traffic management for containers specifically. And that's not actually true for all meshes, because some meshes do provide traffic management for workloads that are outside of Kubernetes. But for the most part, we are talking about providing traditional load balancing, application delivery, and application security to your workloads living in Kubernetes.
And we have a graphic that I think has made its rounds on the internet. I don't have a source to cite, I wish I did. But this is our overly simplified picture of Kubernetes traffic management, with that traffic coming in. And the first thing it hits is your ingress controller. And the ingress controller is operating at that L7 level by default. What a lot of people don't necessarily realize is once it gets down lower, it gets into L3 and L4. And so before we talk about even where a mesh fits in, Kate, why is it concerning that you would start out with L7 but then end up with L3, L4 between your pods and services?
Yeah, I think there's a gap there, right? You want that layer 7 intelligence to extend from where the traffic enters the cluster all the way down to the application container itself. That will give you the best idea of the application health and the most control over the traffic throughout the cluster.
And security is a key part of that, right?
Yeah, absolutely. You want to secure the request from where it originates to the destination all the way through.
So what's really happening here with the service mesh is it's enabling you to have up to that L7 management between the pods and services. That's where it's taking over from the ingress controller. But what we really want to emphasize, because we hear it a lot, is you want to be sure that you're ready for a service mesh before you adopt one. And I think where the industry used to be is, will I need a service mesh? Like a binary yes, no question. And we're not really there anymore. At this point, we're seeing the way that people are adopting containers and microservices, Kubernetes, is at some point, if you continue on that trajectory, you're going to be ready for a mesh. You're going to need that advanced functionality. But there are definitely risks for adopting it too early. And so in just a sec, we'll walk through our infographic on how you know you're ready. But let's talk about those risks. So complexity, complexity, more complexity. But what else? What's going to happen if you go out and adopt a mesh when you aren't mature enough as an organization?
Yeah, I mean, I don't want to, I have to reiterate complexity, because even though a service mesh can add a lot of visibility and management tools for Kubernetes, it does add complexity to an already very complex system. So if you don't understand Kubernetes well enough and you add a service mesh to your stack, it can make things really complicated.
Yeah.
Um, and then in addition to complexity, there's also cost. So service mesh can drive up costs in some situations. If it's not implemented without a deep understanding of your application's architecture, or if it's just managed improperly. And then finally, it can take a lot of resources. You can have a whole team dedicated to rolling out a service mesh if you aren't prepared to do so.
Yeah, lots of human resourcing required to get that mesh to run, depending on what mesh you're using. So
Mm-hmm.
this infographic that we're using, it's also available on our website if you want to take a look at it in more depth. But we're going to run in roughly, like I would say, a chronological, from 1 to 6 being, you would typically hit them in that order. The more of these questions or statements you can say yes to, the more likely you're ready for a mesh. And there's a really good reason behind each one. So we're going to start logically with number one. Number one, you're fully invested in Kubernetes for your production environment. Kate, what does that mean?
So it means you either have production services already running in Kubernetes, or you are getting ready to migrate your production services to Kubernetes. I think the most important part here is that you have already settled on and invested in Kubernetes. You have the buy-in from higher ups as well as your development teams, and you invested in the training and education that's required to adopt Kubernetes.
And then number two, moving right along, you require a zero trust production environment and need MTLS between those services. Why is this a prereq for a service mesh?
Well, I think we see it as like the biggest driving factor in companies adopting service meshes. It's definitely one of the primary use cases. So, in a lot of cases, the need for this zero trust environment and mutual TLS between services arises from their application handling sensitive information. So, this might actually be a mandate that's placed on your team from someone higher up in the organization.
Mm,
Uh,
like an
and
end-to-end encryption mandate or something like that, right?
Exactly. Yep. And even though like MTLS is something that you can definitely roll out on your own, it can be really challenging to do so. I mean, think about managing the life cycle of workload certificates. You need to issue them, the workloads need to obtain them somehow, and then you need to rotate them whenever they expire. So it's a lot to take on for every service in your organization or your application. And Service Mesh gives you an easy and relatively quick way of achieving this mandate.
Moving on to number three, when you think about what a service mesh does, this one makes a lot of sense. Your app is complex in both number and depth of services. Logically, if you have a simple app that's not communicating with components inside the cluster, you don't have a need for that layer, right?
Yeah, absolutely. I mean, primarily, Service Mesh is meant for those extremely complex and very distributed applications. So, like you were saying, if you have a simple application, maybe the architecture is just very straightforward, or it's just a smaller application with not too many different microservices that comprise it, you might not need a service mesh at that point. But that being said, it's definitely a good time to start experimenting with one when you don't need it and when there's not a lot of pressure to deliver it.
That's a really good point. You get a lot more leeway if it's not a critical business need at that point.
Yeah, exactly.
Number four, kind of moving away from the theme that we've been on. Now we're talking about having a mature production CI/CD pipeline. Kate, what do you consider to be mature, and why does that matter for a service mesh?
So when I think of a mature CI/CD pipeline, I'm thinking of a pipeline that's used in order to deploy your microservices in production or to, say, test a development environment. You also want something in place to easily roll back if you encounter errors. So we really see this as an indicator of how far along you are in the adoption of microservices. Because the farther along that you are, the more robust a CI/CD pipeline you're going to have because microservices are very complex to deploy. Um,
Right. If you're doing it all manually, it's probably not production grade. It's too much overhead to be able to automate all that.
yeah, exactly.
Or if it's not automated. Yeah.
One person touching every single component to roll out an entire application isn't sustainable, right?
Hmm.
And we really like to see a mature CI/CD pipeline when you adopt a service mesh because, in the same vein, service meshes are going to be more complex to manage manually than they are if you're just rolling them out in your CI/CD pipeline that you already have in place.
Yeah, and in terms of a stack, you're probably using a tool like Git or Jenkins, Artifactory, Selenium, the like.
Hmm.
So that can be a good
Definitely.
clue as well. Number
Absolutely.
five, kind of similar, you're deploying to production frequently, at least once per day. Why does frequency matter?
Yeah, so this is really a combination of the previous two slides. So if you're deploying to production frequently, like once per day, then you probably have a complex enough app that it requires you to do that. Maybe it's comprised of, 100 microservices and they change frequently. So you're going to need to deploy to production pretty often. It also usually points to having a robust CI/CD pipeline in place because if you're deploying to production once a day, you're not doing that by hand.
And this is where we find most people, they might have said yes or kind of up to this point, but no is the common answer to this one, right? We don't have a lot of people that have really realized this dream goal of constant revisions.
Yeah, I mean, I think it's definitely a lofty goal, and it's not for every application. And just because you're not deploying to production frequently doesn't mean you wouldn't benefit from having a service mesh. We just typically see These types of applications that do have constant revisions really benefit from the advanced traffic routing policies that a service mesh offers, such as traffic splitting for canary, blue-green, A/B deployment scenarios.
Makes sense. Up until this point, we've been talking pretty much exclusively about the technologies that you have in place or the processes that you have in place. But number 6 diverges from that and talks about the people. So your DevOps team is on board. They're ready to try this new tool. They're into modern app deployment. I think it's pretty self-evident why that's important, but what do you see as being the really like the important key here?
I think you want your DevOps team to be bought into what the service mesh is going to bring, what pain points it's going to solve for them specifically. You want them to understand why you're rolling this out. You need them to be on board and to be excited about implementing it.
Sounds great. So, as a listener, no matter where you are in this process, whether you said yes to all of them, no to all of them, 50-50, it's good to kind of do this temperature check periodically. And I like what Kate said. It's better to adopt a mesh before you need one so that it gives you an opportunity to play with it. So let's segue into when you need a mesh. How are you going to select it? We have a kind of a 3-step, 3-part process that we suggest here. And this first step gets skipped a lot. I was literally talking to someone just a little bit ago who was saying, tell me the reasons people adopt service meshes. And the response they got was, well, they've got this list of requirements. And it's like, whoa, 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 time out. Why are you looking for a mesh? What are you hoping to solve for? If you don't know what that is, you're never going to be able to generate that requirements list. So we've got these 4 common use cases ordered generally in order of both importance, but what people are typically looking for first. Kate, would you say that these are table stakes for a service mesh, that they do them all?
Um, I would say yes. It's market standard for service mesh to offer these like 4 use cases or to solve these 4 use cases. But it might not be important for the application. Maybe secure traffic is the most important thing that they need, and that's what they're looking for out of a service mesh. Or maybe they're more interested in the like load balancing, circuit breaking, all those traffic policies that a service mesh can provide.
That's a really good point. They may all be capabilities that the mesh can do, but being really crisp on which one or 2 are the most important for your needs and are actually going to solve what you started out looking for a mesh for is going to help you make sure you narrow down those choices. The second question that we suggest people ask is, how are you going to use it? And you can't answer this question unless you're answering it from the lens of who you are. And we see 2 general categories when it comes to service mesh users. One is the developers, and the other is what we would call a platform or an infrastructure team. We're seeing that being more common, that organizations running Kubernetes in production have some kind of a Kubernetes platform team. Maybe in the past, it might have been called the infrastructure team or even a NetOps team that has moved into Kubernetes. So let's talk about the developer side. These are a couple of use cases that we see are common if the developer is the one using the mesh. They might be adding security to a legacy app that's moving, or they're going to refactor it. Do you see either of these being more common? Are there other reasons developers might be using a mesh?
I think the first use case of adding security to a legacy app is pretty common, especially when you have a mandate from higher up in the organization for MTLS between all services. Adding a service mesh is really going to make that simple, right? Because it's something that you essentially get for free by deploying a service mesh.
Great point.
And I feel like the other use cases for the developer side is you really want to enable the developers to focus on implementing their features that solve, the business concerns of their application. So you can offload some of these other use cases that we talked about, like implementing rate limiting across your entire application. You can offload that to the service mesh. You can have admins take care of that rather than having every developer and every team have to worry about how they're going to implement rate limiting for their service. So I think that's
Mm,
another aspect of
that's
what
a good use
developers will
case.
use. Yeah.
Yeah, if they're concerned about building it into every single app or service, that kind of takes it a layer up. Going over to the platform team, what we've seen is platform teams looking for something that they can add into a CI/CD pipeline to be able to automatically deploy it, in all likelihood to be used by a developer, right?
Yeah, definitely. And I feel like the other end of this is that this platform team, they really want ownership over the realm of responsibilities they have, like application security, reliability, and monitoring. So rather than allowing every development team to, again, like implement MTLS or implement rate limiting however they want to, where you now have like a hodgepodge of different implementations, you have one team that owns the implementation of all of those um, features, and they can truly control it in one place with one product, right? And they don't have to worry about managing a bunch of different implementations of it.
Yeah, it's going to make troubleshooting, uptime, all that so much easier.
Exactly.
Moving on to the last question in this three-step, like what you're walking yourself through, is what factors are going to influence your selection? So this is the requirements, right? Does it need to be infrastructure agnostic? Let's start there. What's the value here of infrastructure agnostic or not? Why would you be looking at that?
Yeah, so I think the benefit of it being agnostic is that you can start by having your cluster run on-prem, and you can deploy a service mesh on-prem and it works great. And then you can decide, well, actually, I think we'd really benefit from using like an AWS hosted Kubernetes cluster. And you can transition to that AWS cluster without having to go find a new service mesh, right? If you don't care about that, say you're really bought into AWS and you're not migrating off AWS anytime, then maybe you go with an AWS specific service mesh that will exactly fit your use cases.
Mhm. Another area that we hear a lot about is compatibility with tools that are part of your stack already, visibility being a really big one there. What are the visibility tools you see as being most common that people care about?
Yeah, the ones I hear about the most are Grafana and Kibana, I believe.
Hmm.
And some people already have this visualization in place and they just want the service mesh to tie into it. Whereas others are really looking for a service mesh to fill that gap. And so they're looking for someone that has a really advanced dashboard that comes out of the box.
Yeah, and then another category is how it integrates with your other traffic management tools, right? Your ingress controller, what that relationship is. There's not necessarily a guarantee that every service mesh is compatible with every ingress controller and that it's going to provide the same, not just features, but like user experience, depending on which ones you've got paired up.
Yeah, I think you definitely need to consider how you're going to handle your ingress and egress traffic when it comes to your service mesh. And like you said, different service meshes handle them different ways. You know, some service meshes come with their own gateways or ingress controllers, whereas others just encourage you to use what's out there in the community. So just
Hmm.
figuring out what's important to you, and then also looking into like ease of use, how it integrates, um, like what features you can get out of that integration, and so on.
And of course, there's other considerations like Kubernetes native, being easy to use, et cetera. So once you've worked through these questions, you're probably going to have a really solid list of requirements from which to start evaluating options. Okay, now that you're ready to select a service mesh, we want to encourage you to think about the data plane. And I'll give you a metaphor to sort of place this into context. So think about, plumbing, and often traffic management gets equated to plumbing. Uh, you've got the plumbing that's visible and is controlling everything. So your faucets, your sinks, your flashy stuff that's inside the house. And then you have the plumbing that's underground that's actually taking your water or sewage, whatever it might be, from the street to the house to the street. In service meshes, most service mesh developers tend to focus on that control plane, the inside plumbing, the sinks and everything. And it's to the detriment of the data plane, the plumbing that's hidden behind your walls and in the ground, which as a homeowner, I can tell you that's the expensive part if it goes wrong. Uh, so Kate, we've been really intentional with NGINX Service Mesh of prioritizing the data plane equally to the control plane, or if not more important. So tell people why that is, what we've done a little bit differently, and why they should think about the data plane.
Yeah, so the data plane is important because it touches every bit, every packet between your consumer and your application. It's the first mile and it's the last mile. So it's the first mile because the ingress controller, which is also a part of the data plane, is the very first thing that handles your traffic. And it's the last mile because the sidecar is the very last thing that handles the traffic before it gets to your application. It's also important because if your data plane isn't resilient, then your application won't be either. It's also the security enforcement point in your application, as well as the traffic policy enforcement point. It provides metrics and monitoring, which enables you to get real-time data on the status and health of your application. Really, like all the logic and value is in that data plane, and the control plane is just a mechanism to orchestrate the data plane. The data plane is just the most critical part of your infrastructure and handles all that traffic from the consumer to the application. So
And that's where you can really pick up speed, right? Or,
yeah,
move those packets
absolutely.
faster.
Absolutely. And at NGINX, because we have NGINX Plus, which is this extremely fast, reliable, secure data plane, we think by investing in data plane first, we can make the biggest impact when it comes to latency of running a sidecar in every pod.
And we should note that for anyone who's familiar with NGINX Plus as a licensed product, with NGINX Service Mesh, it's included for free. It's a free product. You get NGINX Plus for the low, low price of nothing. So it's a pretty good deal. You did mention ingress. Let's look a little bit closer at that north-south. Why is it important that these two things connect so well?
So I think when we talk about data plane and service meshes, typically we focus on that sidecar to sidecar communication. And we tend to overlook the north-south traffic. So the ingress controller is also a part of the data plane. And if it is the same technology and is managed in the same way as the sidecar data plane, it's going to make all of your traffic management much more simple. The user has like one unified approach to all traffic, north, south, and east, west.
And is it common to have that managed all in one place?
It is not super common, no. And there's also a bigger focus on ingress traffic than egress traffic in the market right now. So NGINX Service Mesh is really focusing on that egress traffic. And we believe that it's just as important as controlling what's coming in the cluster is controlling what's going out of the cluster and being able to apply the same traffic policies and security policies to your external routes, meaning the requests made from inside the cluster to a service that's running outside of the cluster, as it is to apply those same policies to your ingress routes.
Okay, and we're starting to come into the end of our session here. So we'll give a quick overview on NGINX Service Mesh, and you can kind of see where it fits in to a Kubernetes architecture with that ingress, egress on the edge, the north-south, and then, controlling management between services. There's three big reasons why we thought this was a project worth developing. So it's around that developer-friendly feature. So Kate, why do you think NGINX Service Mesh is so developer-friendly?
I think first and foremost, it's just really easy to use. The deployment experience is very quick. There aren't like a lot of options that you need to worry about. And then after you deploy it, you can really just set it and forget it. It manages itself. It doesn't need a lot of oversight or constant tinkering and configuration.
And then we already touched on the second area being powerful and efficient. That's all about the NGINX Plus sidecars, right?
Yeah, I think this point is also about our control plane in that it's very fast and lightweight and Kubernetes native. So when I say Kubernetes native, I see the biggest benefit of that as you not having to learn a whole new tool set just to run a mesh, right? You can use the same constructs that you use to create resources in Kubernetes to create traffic policies with our service mesh. So you don't need to learn a new configuration language or anything like that. You can just take your Kubernetes knowledge and run with it.
And then the NGINX Plus sidecars, you alluded to some of the benefits of using NGINX Plus as a sidecar earlier. It's everything from traffic shaping to traffic splitting to what else? Why does it matter?
I think it matters because it's a tried and tested reverse proxy application delivery controller. Nginx Plus provides you with a ton of features, like you mentioned, as well as just being fast, reliable, and has that really small footprint that people are looking for.
And that brings us to the end. Kate, as always, it's great having you here. Thanks for joining us.
Yeah, thanks for having me. I hope everyone enjoyed it.
So if you want to learn more about Service Mesh, we have resources available in the resources section. And if you missed any of our other microservices and Kubernetes session, including a demo on using Nginx Service Mesh, those are going to be available on demand. Hope you enjoyed Sprint.